everyone. I am Bhaskar, Assistant Professor, Department of Information Technology, V.S.B. Engineering College, Karur. In this video, we are going to discussing about introduction about the microprocessor. In this microprocessor, we want to see about the basic outline of the processor. First of all, the block diagram of the computer system. Second is the basic component of the computer block. And the third is the evaluation of the microprocessor. What are the types, byte of data we are going to use in this microprocessor? And the next one, the word length, long word. About this, what are the bits we are going to use in this processor? Fetching and execution of the processor. And the bus system. What are the bus system we are utilizing in this microprocessor? And what are the types of microprocessor? All the outlines we are going to discussing about from this sessions. Basically, microprocessor is a single chip device. It is a device in which capable of addressing 64 kilobytes of the data. This data we are utilizing about 64 kilobytes, 128 kilobytes, and 160 kilobytes. Something like that we are going to utilize in this microprocessor. In this microprocessor, we have to use the address bus and data bus. Address bus is basically it is a unidirectional one, and data bus is a bidirectional one. Address bus it is points to the corresponding memory location of the data, and the data bus it is communicating between the microprocessor and the peripheral devices. And these are the bus data we are utilizing in this microprocessor systems. Basic block diagram of the computer system in this microprocessor we are using for this computer system as CPU and a memory, different types of memory of the microprocessor we are using this computer system. And the basic components are central processing unit, arithmetic logic unit, and different types of interrupt and different flag we are using in this case of microprocessor. And next for the input and output devices we are utilizing this microprocessor. Next, the evaluation of the microprocessor. In this evaluation we are using different bit rates. Basically 8-bit microprocessor, 32-bit microprocessor, and a 64-bit microprocessor. Something like that we are utilizing this processor. And next for the nippon byte word and long word. Nippon 4-bit, byte is 8-bit, and word is the length of the bytes. Fetching and execution of the cycle. Fetching and execution during the programming time, we have to fetch and execute the data using this different microprocessor systems. And internal structure and basic operation of the microprocessor using the control unit, arithmetic and logic unit, memory interfacing devices, program counters, stack pointers, different flag. We are using this as of the internal structure of the system. Bus system, data bus, address bus, control bus, different memory address bus we are using in this case of microprocessor. Data bus is communicating between the microprocessor devices to some other peripheral devices. It is basically as a bidirectional device. And address bus is a unidirectional one. It is points to the corresponding memory location of the data. It is points to the corresponding pointer values. Control bus it is used to communicate the different devices, input, output, control devices, and bus, different part of the data we are using in this processor system. Clock system we are using the different clock system as 12 megahertz and 12 gigahertz, and different clock system we are using in case of microprocessor. Example of the microprocessor 8085 microprocessor and 8086 microprocessor and 8088 microprocessor, Z80 microprocessor. These are the different types of microprocessor we are using in this case of systems, microprocessor system. And next part is the basic block diagram. Already ignored. We are using the machine cycle and instruction cycle in these computer systems. We are using this central processing unit, utilizing the data, storing the data, retrieving the data. And next are the basic block diagram of the computer systems. It is the basic block diagram of computer system. Input we are using as a central processing unit, ROM device, RAM device, interfacing device, input output devices. ROM is the read-only memory and RAM is the random access memory. It is used to read the data, only read the data for ROM purpose, and RAM is used to read and write the data. At the same time, we are using the address bus and data bus. Address bus, it is communicating between the microprocessor to some interfacing devices. That is a unidirectional one. Data bus is a bidirectional one. It is communicating between the input devices to microprocessor devices. It is a basic block diagram of the computer block systems. And next for is our central processing unit and a Pentium processor we are using in this case of microcomputers. And memory is a random access memory, read-only memory, EEPROM and ROM. These are the devices we are using in the microprocessor memory system. BIOS and operating system we are using in case of computer during on and off purpose. And input and output units. Input unit utilizing the computer, and output unit you have to communicate the different peripheral devices. That is for peripheral devices, programmable peripheral interface, interrupt devices, communication interface, serial and parallel input and output port, and these are the devices you are utilizing under the peripheral device purpose. And hard disk, floppy drive, networking devices, these are not using in the case of input and output of the microprocessor system. And the data size, basically this microprocessor, we have to design the data size, how to use the data in the process during execution time. So that's what we are going for this data size. Data size we are using as 4-bit, 8-bit, 16-bit, 32-bit. Depends upon the data bus, how much we are utilizing in this case of data. That's we have to configure the different processor. Suppose 8-bit data means we have to use for data buses D0 to D7 line. 16-bit means you have to use for the data buses D0 to D15. These are the basic configuration of the microprocessor. We are using the 8-bit microprocessor and a 16-bit microprocessor. Depends upon the data utilizing wise data lines, we have to configure this 8-bit or 16-bit microprocessors. And next, this arithmetic and logic unit, what are the registers we are going to utilizing in this microprocessor about the systems. Register we have to use for the 6 general purpose of registers, B, C, D, E, H, L registers. B, C, D, E, H, L is this and all register pair, and 8085 microprocessor you have to use for the different 6 general purpose of registers. Control bus used to communicate between the different input and output signals. Control signals are ALE, arithmetic and logic unit, control input output signals. These are all the control buses. We are going to using this timing purpose for communicating the input output devices to microprocessor of the systems. And arithmetic logic unit, that is the function of the microprocessor. This arithmetic logic unit used to perform the arithmetic and logical operations. Arithmetic operation, addition, subtraction, multiplications, and a logical operation are AND, OR, XOR. These are the logical operation purpose. We are using the microprocessor. From that we have to perform the arithmetic and logical operations. This is the internal structure of the peripheral arithmetic logic unit devices. This is a 2-bit device. This is a 4-bit arithmetic logic unit. In this case, we are using the carry signal and a different AND gate given to the latches, and these are all the different gate used to give giving to the buffer. From that we are giving the exclusive OR gate. From the output we are giving to the microprocessor devices. And next for control unit. Control unit it is the brain of the systems. It is from that only you have to control the different signals, arithmetic ALU, address latch enable signals, and input output control signals, ALE signals. This and all it is controlled through the microprocessor using this control bus unit. It is managing and executing, decoding the different data using the microprocessor systems. And next for registers. Register different types of register used under the 8086 and 8085 microprocessor. This register used to store or hold the data in a particular registers. Suppose we are using BCDE register pair. This BCDE and all registers. B should store some data and C it should store some data. Something like that you have to use these register sets. It is all those things it is controlled under the microprocessor device. From that you have to execute the program in a easier manner. And this is the different register level. How to using under data register and segmentation, how to utilize in the microprocessor. Data registers D0 to D7, address bus are A0 to A7 and A15, stack pointer and program counter, status registers. Data register D0 to D7, it is using the data lines, and the address register used for the address purpose. This is a unidirectional, this is for bidirectional. Stack pointer used to hold the data, and it is used to read and write the system on the given registers. Program counter used to increment or decrement the data, depends upon the push and pop condition. You have to utilize another program counter. It is push and pop used to increment and decrement the different data items. And accumulator, this is we have to already told it is actually the accumulator used to store the data in a microprocessor systems. It is basically it is set as 8-bit data we are using to store particular register of the data. That is moved from register to accumulator. All the data is finally going to all the data of the program finally going to use under the accumulator only. From that we have to replace the CPU registers, accumulator, everything it is all the data it is initialized and finally stored into the accumulators. And a different flag we are used to set the bits using this microprocessor, such as we are using for a carry flag, zero flag, overflow flag, and carry ahead flag. Carry means if suppose adding the two numbers, that output if it is any carry, it should be set the value should be 1. The output should be 0, that value should be set as a 0 flag. And overflow flag, if it is any flag occur at 0 other than 2 bits, that is the overflow flag we are going to use. And off carry, from the carry, that value should be divided into 2. These are the different flag set the bits using the processor in the microprocessor systems. These are the carry flag, 0 flag, overflow flag, and off carry flag. These are the flag setting the data. These are the flag we are using under the microprocessor systems, and the program counter already told. Stack pointer and this operation one already told. Data bus already told. Address bus is under given the data. Address bus we are using for communicating the unidirectional buses. It is address lines. It is communicating between the microprocessor system to different memory system, RAM, ROM devices. It is a unidirectional one, as well as the data bus is the bidirectional one. I think from this you have to understand about the microprocessor, introduction about the microprocessor, and next for These are the types utilized under the different industrial purpose, application purpose. Intel 8086, Motorola 6800, Z80, and 8086 microprocessor. These are all we are using under different function wise. Thank you.